This is the test review for your Module 1 exam, so make sure you have that printed and in front of you. We're going to start with problem number 1. It says complete the table of values for the equation and then graph the line. And we're given the equation 3x plus 2y equals 10. Now the table of values has been started, so we're going to take the values that were given and plug them into the correct spot in the equation. So here we're going to plug in a 0 in the x spot. That would give us 3 times 0 plus 2y equals 10. 3 times 0 is just 0. Divide by 2 and we end up with y is equal to 5. And we'll plot those points after we get all of them. This next 0 is in the y column, so I plug a 0 in for the y and I get 3x equals 10. We divide by 3 and we get x equals 10 thirds. Now because we're going to be graphing this, I'm going to go ahead and change 10 thirds to a mixed number because it'll be easier to locate on the coordinate plane. So that is 3 1/3, so just a little bit past 3. Next I'm going to take the 2 and put it in for the x. That would give me 3, take out the x, put in the 2, plus 2y equals 10. 6 plus 2y equals 10. Subtract that 6 from both sides. We get 2y equals 4. Divide by 2 and we get y equals 2. So we have another point. Now we have more than enough points to do our graph, to plot this points and graph our line, but we have to continue to complete the xy table. So we now put in -2 in the y spot, so 3x plus 2, take out the y, put in the -2, or 3x minus 4 equals 10. Add a 4 to both sides and we get 3x equals 14. Divide by 3 and we get x is 14 thirds. Again, I'm going to show 14 thirds as a mixed number. That's 4 2/3. That way it's easier to graph. Now let's plot the points. We have the point 0, 5, which is right here. We have the point, remember 10 thirds is about 3 1/3. So 3 and a tiny bit more 0. I'm just going to estimate there. Now that's enough to draw my line, but I want to make sure the other ones fall on that same line. Then we have the point 2, 2, and the point about 4 2/3, -2, which is about here. And you can see they do all line up, and when I connect them, I'm going to use a ruler so I can actually do it correctly. You can see that those points are all solutions to that equation and they line up to make a straight line. All right, let's look at the second question. It says find the x and y intercepts and then graph the equations. So we have x minus 4y equals 8. So we're going to start an xy table. This is different than question 1 where the xy table was already started for you. To find the x-intercept, we put a 0 in the y spot. To find the y-intercept, we put a 0 in the x spot. So let's first find the x-intercept. That would be x minus 4, take out the y, put in a 0, or just x equals 8. That was an easy one. Next, we're going to put the 0 in for the x to find the y-intercept, and we have 0 minus 4y equals 8. Now be careful, don't drop this leading negative sign. So -4y equals 8. I divide both sides by -4 and I get y equals -2. I can now plot those 2 points to graph my line. So I have the point 8, 0, which is right here, and the point 0, -1, 2. I know this is a little small, but you've got your copy in front of you, so hopefully you can follow along on that one. And we have our line. Only doing 2 points on this one. Okay, let's look at question number 3. This falls under the same category as using the X and Y intercepts. So I'm going to start my XY table. However, this one is a little bit different because it's telling you that X has to be -5. Nothing else is allowed. So I'm not allowed to put that 0 in to find the y-intercept, which tells me there must not be a y-intercept. So what do I put in for y? I can put in anything I want because it's not part of the equation anyway. I did not mean to put in 3 zeros. I was talking and writing at the same time. So we're going to put in a 0 there. We're not going to put in 2 more zeros. Let's put in a 2 and a -2. I can pick anything I want, again, because there is no y in that equation. It's been multiplied by 0 and is gone, so it doesn't matter what you pick for y. So we have the point -5, 0, -5, 2, and -5, -2. I think I hit -3. These are so little it's hard to see. But it's obvious what I end up with is a vertical line. And that vertical line does not intersect the y-axis, so I do not have a y-intercept. I do have an x-intercept, and that's this point right here, the point -5, 0. All right, looking at the next page, it says find the slope of each line. So this section is on slope. Let me get this kind of straightened up for you so I don't make you seasick. So let's start out finding slope through the points -1, 2 and 4, -5. So the first thing I'm going to do is x1, y1. I'm labeling x2, y2. And now I'm going to use my slope formula. M equals y2 minus y1 over x2 minus x1. And now, being very careful with signs, I'm just going to fill in. So I'm going to have -5 minus 2, that's y2 minus y1, over 4 take away -1. This is where you have to be careful with signs. It's not 4 minus 1. It's 4 take away -1. I have a -7 on the top. Those two negatives make a positive. I have a 5 on the bottom, and my slope is -7/5. Question 5 is asking us to find slope, and we're given an equation. So what we're going to do here is get that equation in y equals mx plus b form, because what sits in that form, m is the slope. So I'm going to do that by subtracting the 2x first. That's going to give me -y equals -2x minus 3. Always write your x term first so that it looks like this. Now I'm not quite there because this is a -y. So I have to divide each term by -1, and that is going to give me a negative divided by a negative is a positive y. Again, a negative divided by a negative is a positive 2x. Negative divided by negative is another positive. And I have my equation in this form. So I know my slope is the number in front of the x, the coefficient of x. So here, my slope is 2. And we got it by rearranging that equation. This next one is a little different. X equals 5. What you have to remember is that an equation, any equation in the form of x equals some number, is always going to be a vertical line, just like the problem that we did. I believe it was number 3 on the page prior to this. This is a vertical line, and any vertical line on my coordinate plane, no matter where it is, has slope undefined. It's so steep we can't define it. So you would just say the slope is undefined on that one. The next one is similar. Y equals -10. You need to realize that y equals some number is always a horizontal line. And a horizontal line, again, no matter where it falls on the coordinate plane, always has slope equal to 0. And by the way, these two things are not the same. Undefined is not the same as 0. Now, if you should forget which one of these is vertical and which one is horizontal, you could always do, let's use this one as an example. You could do an XY table and say, well, Y has to be -10. X can be whatever I want. Now I'm going to use those 2 points, and I'm going to use my slope formula up here to find the slope. It takes longer to do it, but you can certainly do it that way. All right, let's look at number 8. It says perpendicular to 3x minus y equals 4. We want to know what the slope of our line is if our line is perpendicular to this line. So the first thing we have to know is what is the slope of this line. And we're going to find that the same way we did up here in number 5 when we rearranged the equation. So we're going to rearrange into -3x. So I have -y equals -3x plus 4. Now I'm going to divide by -1. I get y equals negative divided by negative is positive, so that's a 3x. Positive divided by negative is a negative. So what I know is the slope of this line is 3. Now if my line was parallel to that line, that would also be the slope of my line. But my line is perpendicular. Perpendicular slopes, our perpendicular lines have slopes that are opposite, meaning opposite sign, and reciprocal. So think about, this is a positive 3/1, so my slope is a negative, and now the reciprocal of this, 1/3. So you use the information that you're given to find out what you need to know. In example 9, we're given a graph, and we want to know the slope. So we're going to use the definition of slope, that slope is rise over run. And I'm going to pick this point and this point because those appear to be the 2 intercepts. And we're going to count to see what our slope is going to be. How much does it go up and then over to get from one point to the next? So starting with this one, and I'm going to do it in red so you can see the difference here. I'm going to go up 1, 2 in my travel to the other one. So I went up 2, and then I go left 2, left 2. Up is a positive direction, left is a negative direction, so I end up with slope of -1. Now, let's say we went the other direction. We start with this top point and we come down to the bottom one. To get there, I have to go down 2, and then I go right 2. Well, down is a negative direction, right is a positive direction, and I still end up with -1 for my slope. So it doesn't matter which way you count, you just have to remember up and down goes before left and right because it's rise over run. All right, next page, number 10, it says, are these 2 lines parallel, perpendicular, or neither? And show your work. So what you do not want to do is graph them and then try to guess if they're parallel or perpendicular. That's not accurate. What you need to do to be able to tell what the 2 lines are is to find the slope of both of them. So we're going to rearrange this equation. We get -y equals -4x plus 2. We're going to divide each term by -1. Y equals 4x minus 2. Therefore, the slope of this line is 4. Now I have to know the slope of this line. So I'm going to rearrange that equation. -4y equals -x minus 8. Divide here by -4. And I get y equals a negative divided by negative is a positive. And this is an implied 1, so that's where you get the 1/4. X, negative over negative, is a positive 2. So the slope of this line is 1/4. Now we have to compare those 2 slopes and draw our conclusions. Yes, they are reciprocals, but they are not opposite reciprocals. They're both positive, so they're not perpendicular because they're not opposite reciprocals. They're also not the same, so they're not parallel. So what they are is neither. They're just two lines that intersect at some point. They're not parallel and they're not perpendicular. Number 11, it says write the equation for each line, and I'm going to tell you this is an incredibly important section. Make sure that you understand these, even if you have to watch this 2 or 3 times. So we're going to write equations of lines given information. So in the first one, we're given the slope, so we're given that m equals negative 1/3, and we're given the y-intercept as 0, negative 1. That means b is negative 1, because in the equation y equals mx plus b, remember this is the slope, this is the y-intercept number right there. So since I'm given both of those things, all I have to do is plug them in. So y equals negative 1/3 x minus 1, and I have my equation of my line because I was actually given all the information that I needed. I didn't have to do any kind of calculation. The next one says, find the equation of the line passing through the point 2, negative 5, and 1, 4. Okay, so in the margin, you want to go x, y, m, and b. This is how I showed you in the notes on this section. Let me move that over so you can see it a little bit better. The two things that I have to write my equation are m and b, just like I did in number 11. So here, I don't have an m or a b. I have plenty of x's and y's. I have 2 of them. I'm going to pick this second one as the one I want to use because they're positive. You can't pick an x from one and a y from another, so don't think about that. You have to use the whole point. Now I'm going to label these x1, y1, x2, y2. Why do you think I'm doing that? Because I have to have the slope. So I'm going to use those 2 points to find the slope. So y2 minus y1, being careful of signs, x2 minus x1. 2 negatives make a positive, so that's 9 over negative 1, or just negative 9. So my slope on this one is negative 9. So here we did a find m. Now we have to find b. And this is the part where you have to use each of the 3 variables that you know, the x, the y, and the m that you just found. So we're going to start with y equals mx plus b. Fill in the parts that we know. Y is 4 equals m times x plus b. 4 equals negative 9 plus b. I add a 9 to both sides and I get b equals 13. So now I am back to one like number 11, where I have the m and I have the b. I found the 2 things I needed. So I'm going to write the equation. Let's write it over here where we have a little more space. We go back to the generic form of the equation, this form where you just fill in the m and the b. Y equals negative 9x plus b is 13, and you have the equation of the line. That one had a lot of work in it. All right, let's go to the next one. It's a vertical line, that's the key here, that goes through the point 2, 5. Well, vertical lines all have the equation of x equals some number. So all you do is look at what the x is. It's a 2. It's x equals 2. That is the equation of that line that goes through the point 2, 5, and it is vertical. Next we have, find the equation of the line that's parallel to 4x minus y equals 3, and it passes through 7, negative 1. Again, I'm going to go to the margin, x, y, m, and b. Fill in the parts that I know. I know that x is 7, Y is -1. I don't have the M or the B, but I can get the M because my line is parallel to this other line. So if I knew the slope of this line, I would know the slope of my line. So I am finding that slope by rearranging and getting my equation in y equals mx plus b form. The slope of this line is 4. Right there it is. And since my line is parallel, my slope is 4. And now we're right back to where we were on the prior problem when I had slope as -9. I now want to find b. The way we do that is we fill in y equals mx plus b with the pieces that we have. So -1 equals m times x plus b. -1 equals 28 plus b. Subtract a 28 from both sides, and I get b equals -29, and I now have the pieces that I need. So I fill them into the generic equation. Y equals mx plus b. By the way, don't use double signs. Don't write plus -b. A plus times a minus is a minus, so just put in one sign, please. All right, the last one on this page is a literal equation, and we are to solve for b, which means we need to rearrange. Because I have a denominator, the first thing you want to do is multiply by the LCD, which is just 2 in this case, both sides. That gives me 2a equals, the 2's cross cancel, h times b plus little b. Now the letter that I'm looking for is in parentheses. I need to get it out, so I'm going to distribute. So 2a equals h big B plus h little b. Now I want to isolate the term that contains my variable b, so I'm going to isolate this by subtracting h big B. I'm going to write it up here. So that gives me 2a minus h big B equals h little b. And now the only thing left to do is to divide by h. Now I want to show you something. These h's will cross cancel because those two terms were multiplied together. These h's will not cross cancel because this is a subtraction sign. So this top is a unit. So you're going to write b equals 2a minus h big B over h. If you are unsure as to whether it will cross cancel or not, don't do it. You're always safer to err on the side of not simplifying. All right, let's look at the last page that we have here in this review. We have some application problems and some material on linear inequalities. So it says, suppose there is a flat rate of 20 cents plus a charge of 10 cents per minute to make a telephone call. Write an equation that gives the cost, which we're going to call y, in dollars for a call of x minutes. Here's the way I'm going to do it. I'm going to say the total cost is going to equal the flat rate, 20 cents, plus 10 cents per minute, means times how many minutes there are, which is x. Now all I have to do is replace the word cost with the y, and I have my equation. My flat rate, you can leave off that 0 if you want, plus 0.1x, and I have the equation that I can use to find the cost of a call. So part B says, what is the charge for a 15-minute call? Well, the total charge would be the flat rate, you got to pay that no matter what, plus 0.1 times 15 minutes, because x is the 15 minutes, or y equals 0.2 plus 1.5. The total cost is y equals $1.70. You're going to put that 0 back on since we're talking about money. Now on these next two, I'm going to use colored pens so it's a little bit finer and a little bit easier to see. So let's look at the first linear inequality, and then we'll do a compound one. This one says graph a solution of each inequality. So number 17, I have 5x minus y is greater than 6. So the first thing that you do is you write the boundary line equation. That is the same equation, but you have an equal sign instead. So 5x minus y equals 6. Now I need to graph that line. So I'm going to start an xy table. Because my y has a 1 in front of it, I'm going to pick values for x. It'll make the arithmetic easier. So I'm going to start with 0. So that would be 5 times 0 minus y equals 6. Negative y equals 6. Divide by negative 1, and we get y equals negative 6. So there's our first point, the point 0, negative 6, which is right there. Now, I need one more point. I'm still going to pick for x to make easy arithmetic, so I'm going to pick a 1. That would give me 5, take out the x, put in the 1, minus y equals 6. 5 minus y equals 6. I'm going to subtract that 5. I get negative y, don't drop that negative, equals 1. Divide by negative 1, and we get y equals negative 1. And I have a second point, the point 1, negative 1. Now, you're going to go back to your original equation. This symbol tells us that we are talking about a dotted, not a solid line. So I'm going to lay my ruler down on these 2 points, and I'm going to draw a dotted line going through them like this. And now I have to figure out which side of that line should be shaded. So the next step after we use the graph and find our line is to test a test point. And as long as your line doesn't go through the origin, we're always going to test the point 0, 0. It's just easier. And you test it back in the original inequality that you were given. So 5, take out the x, put into 0, minus, take out the y, put into 0. Is that greater than 6? Is 0 greater than 6? No, that is totally false. So what that tells me is that the point that I tested, 0, 0, right there, is not accurate. It's not in the right region. So I'm going to shade the other region, the region that does not contain that point. So even though it didn't work, the point didn't work, it still tells me what region to shade. All right, let's take a look at a compound inequality in question number 18. 2x plus y is less than or equal to 1. I'm going to go ahead and write that's going to be a solid line because of the or equal. X is greater than or equal to 2y. That one is also a solid line. So let's start with our first equation. Its boundary line is 2x plus y equals 1. I'm going to, again, pick 2 points. Since the y has a 1 in front of it, I'm going to pick for x. I'm going to pick the points 0 and 1 just because they're easy. So if I pick 0, it would be 2 times 0 plus y equals 1, or just y equals 1. That was an easy one. So I have the point 0, 1 as my first point. Now I'm going to put in a 1 for the x. That would be 2 times 1 plus y equals 1. 2 plus y equals 1. Subtract a 2, and we get y equals negative 1. And I have my second point, 1, negative 1. And in this case, I can connect drawing a solid line. Now, it's close to going through the origin, but it doesn't go through the origin. So I can still use 0, 0 as my test point. So I'm going to test 0, 0 in that first equation. So 2 times 0 plus 0 is less than 1. Is 0 less than or equal to 1? That is definitely true. So in that case, since 0 is less than 1, that means that my point 0, 0 was in the correct region. So in blue here, I'm going to shade the side that included that point that worked. 0, 0 worked, so I'm going to use that. Now, we're not finished. That's the first piece. I'm now going to go to my second one. I'm going to do this one in red. So secondly, I write the boundary equation for that one, which is x equals 2y. Since x has a 1 in front of it, we're going to pick values for y. So I'm going to pick a 0 for y. That would mean x is 0, and that means, uh-oh, it goes through the point 0, 0. So I'm not going to be able to test 0, 0. Now I'm going to pick 1 for y, and x is equal to 2 times 1, or x is equal to 2. So I have the point 0, 0, which is right here, and the point 2, 1, which is right here. It's also a solid line. So we're going to draw this solid line, and now is where this is a little bit different. I can't use the point 0, 0 to test because my line goes through that point 0, 0. So I'm going to pick some other point, and it doesn't matter what point you pick. I'm going to pick the point 3, 1, 2, 3. I'm going to test this point right there. I'm going to test 3, 3. Just pick a point somewhere off the line. It doesn't matter what it is. 3, 3, and see if it's in the right region. So I'm going to go back to my original equation, and I'm going to say x3 greater than or equal to 2 times y is 3. Is 3 greater than or equal to 6? Absolutely not. That is false. So what does that tell me? That tells me that my test point of 3, 3 does not work. So I can't shade the region where the 3, 3 is. I have to shade on the other side of that line. I can't shade up here because that contained the point. That didn't work. So I shade down here like this. And now, because my problem said and, what it's asking me is, where do you see the double shading? And I think it's obvious. I'm going to make this kind of dark. The double shading is between these lines. This is where you have the red and the blue, and that's what that means. Where is the double shading? So this is red and blue, just red. This didn't work.